The JSON Data Requirements and Geometry Validator is a standalone application that can be used to validate the presence and characteristics of city objects in a set of CityJSON and/or CityGML documents, as well as the correctness of the geometry primitives contained in them. The validator leverages semantic technologies, especially the Resource Description Framework, or RDF, to perform this task. RDF is a framework for describing and exchanging definitions and metadata of resources. A resource can be anything, ranging from physical objects to documents to abstract concepts. A chair, the Andromeda Galaxy, the complete works of Stephen King, or lawlessness are examples of resources that can be described using RDF. RDF follows a subject-predicate-object pattern to describe and link resources, conceptually forming a graph. For the validation process itself, the Shapes Constraint Language, or SHACL, is employed. SHACL allows for defining validation rules, known as shapes, to verify the structure and metadata of an RDF dataset. Each SHACL shape can be applied to a subset of objects within a dataset, resulting in a validation report with details about those which are non-compliant. The graph-like nature of RDF makes it possible to define constraints of varying complexity, from simple property checks to rules involving the interrelationships among multiple objects with different types and characteristics. This diagram shows the overall workflow followed by our application. We have two sets of inputs, city data that we intend to validate, in pink, and a series of rule collections, or profiles, which contain the validation requirements, in green. The system supports CityJSON as well as other metadata, such as inspired datasets, as its input. Input data is transformed into semantic format, specifically RDF, through a step called semantic uplift, which maps the CityJSON objects and properties to a custom RDF data model. Different rule collections can be defined, each with a set of rules codified as SHACL shapes, as well as some metadata properties. The definitions can also contain variables, which act as placeholders whose values can be provided by the user at validation time. For example, a rule may need to perform checks on a given building, or building of interest, but the identifier for such a building will remain unknown until the user specifies it when performing the actual rule checking. Inheritance relationships can be established between rule collections, meaning that a given collection can automatically and recursively import rules from others, focusing just on specialized and specific requirements. For example, a geographical hierarchy can be defined so that the rule collection for a given city imports the rules from the region containing it, with the regional collection, in turn, importing a set of national rules. Rule collections are stored in a semantic database, also called triple store, and can be accessed through systems such as the OGC Rainbow. Running a validation job requires selecting the input data files and one or more rule collections, as well as filling in any input parameters defined by the collections, at least the required ones. Once validation is finished, a machine-readable report will be returned by the service. This report can then be presented to the user in a human-readable format. Additionally, we can validate other formats, such as CityGML, by converting it first into CityJSON, in this case using the CityGML tools library. Interfaces can also be developed to define the SHACL-based rules in a user-friendly manner, especially for the more common use cases. Moreover, apart from verifying data requirements, several validity checks are performed on the geometries used throughout the city documents, employing the Val3DT application developed by TU Delft. The result of this validation is also included in the final machine-readable report. The validator is published as an OGC API Processes compliant web application, meaning it can be easily integrated with other platforms and services. Its source code is published on GitHub, along with instructions on how to execute it. Docker images are provided for convenience so that instances can be deployed in different environments. For example, a municipality or a group of municipalities can deploy their own instance with a set of custom rule collections that they can all access and use. Users can also deploy instances in their own individual computers. Documentation on how to configure the application and define new collections and rules is also available. This is an example of the validator running by following the Docker instructions in the documentation. The application provides several OGC API Processes endpoints that can be used by other services and clients. For instance, we can see the list and characteristics of the rule collections available in the service by querying the /processes endpoint. Other endpoints can be used to execute validation jobs, to monitor the status of a given execution, or to retrieve its validation report. The validator also comes with a user-friendly interface composed of a form through which CityJSON documents, or CityGML files, can be uploaded, and the rule collection selected to execute validation jobs. For example, we can use the roads required rule collection to check a set of files with buildings and roads. In this case, some inconsistencies in the geometry definitions are detected by Validity, but no data requirement errors are found. If we remove the roads dataset, we can see how the buildings only one fails the requirements for roads. We can also use rule collections with input parameters, such as the SHACL IP1, which requires a value for the building of interest. In this case, using a made-up identifier results in a validation error. You may notice how the same errors about missing roads are also present. This is because the SHACL IP collection inherits parts of its rules from the roads required one. Updating the identifier to that of an existing building makes that error go away, but new ones related to the levels of detail appear. Behind the scenes, this user-friendly form uses the same OGC API Processes interface intended for third-party integration.